In this video, we are going to be designing raft slab foundation, and this type of foundations take the entire area of the building. Here is the structure we are going to be considering. We will analyze this structure and then proceed to the design of the raft slab successfully. And we will come up with the construction drawing. Here is the first construction drawing we are going to be organizing, and then the reinforcement detail of the raft slab successfully in this video. Stay connected as we make progress into this presentation. All right, so here is the model that we are going to be considering in the raft slab foundation design or floating raft foundation design successfully. Okay, so before we make progress, we will have to ensure that all of the structural members in this model has been designed successfully. So if I navigate to the analysis tab, you can see the building analysis has been carried out successfully. Okay, so before you should design your foundations, you ensure that you have done your building analysis as well. If I go to the structural tree, expand the story one, right here, take the columns right there, you can see that we have all our columns being designed successfully. Then over here, the beams, you can see that it is also being designed successfully. Okay, so having checked that successfully, I'll save this project, and then we have to now navigate the gray lines to story 0 so we can start to model the foundation slab successfully. Okay, so for this type of foundations, we wouldn't need much excavations. Okay, so excavation could be like up to maybe 500 just to remove the topsoil, okay, to some extent, okay, because the foundations actually takes the shape of the structure. Okay, so I will click in the 3D, right click, and then I will navigate to the plan view of the foundations, just like this, you can see. So we navigate to the building modeling tab, okay, and then we are going to be using the slab. Okay, so I click on this slab provision. So in this slab provisions, I will give a slab thickness. I want to use 250 millimeters slab thickness, and then the concrete cover is going to be 50, just like this. And then I come to load. In this load provisions, I will look at the load value as a this is going to be a lower slab, just like this. Okay, so in the imposed load, for the purpose of this structure, is just a residential structure, so we use that successfully, just like this. After which I come back to these provisions. So I'm going to be placing my slab. Okay, the slab type is not an issue. Okay, that will be set automatically. All right, so I will get to where I have an insertion method right here. You can see over here insertion method. So I will be using the options of pick point insertion method. I select that method successfully. So I will pick this point. I pick this point. I pick this point to have my slab just like this. Also, I'll pick from here just a rectangular slab. Okay, if you come over relative level here, you see is this 0 right here, because we wouldn't need to elevate or bring down the slab above the normal level. Okay, so I close this dialog. I want to now be inserting my cantilever slab, okay, which we have, and then give me a kind of a provisions for a kind of an offset, so this column can be properly secured at the foundation. So I come to slab provisions, and then this time around I will use tab type 12, which is the cantilever slab, and then the thickness is going to be 250 millimeters. So the concrete cover as well will be 50, just like this. All right, and then I come to the load provisions. I use the same lower slab options, and then the purpose of the structure imposed load is 1.5 kilonewton per square meters. In the cantilever tab right here, the length of this cantilever I will be having 1200, and then I will have a kind of a backfield load on this cantilever to be 10 kilonewton per meter run. Okay, so now with these settings, I can now proceed. I want to use these options of beam region, but this will not really work. You have to pick 2 points. Okay, the first point, the second point, and then click just like this. You can see. So I pick this point, pick this one, and clicked. So I have just like this my cantilever slab at the foundations, just this way, and then click here to have it insert successfully. Okay, and then this last provision, just like this. So having done this, now we will now have to proceed to the analysis of this Raft slab foundation successfully. But by then, let us navigate to the 3D so we can actually see what we are doing. So this is what we now have. Okay, so we get back to the foundations of this structure. All right, at this point we have to save this project successfully. Have I saved the project? If we come to the analysis tab, you can see we have FA foundation analysis. So this type of foundations here, we use the finite element methods to analyze it. Okay, based on the load decomposed to the foundation successfully. So I will click on this FA foundation analysis right here. So in this FA foundation analysis, I have to include my column sections in the FA model, and then I have considered beams, torsional stiffnesses, okay, torsional stiffnesses, okay. Wooden out beams are these foundations, okay, so I will get rid of that. So I'm okay with the settings. Other settings you should do is this upgrade coefficient, okay. So depends on your soil bearing capacity or the soil report, okay. You always have this on your soil report recommended. This can be changed successfully based on your soil report. But for the sake of these presentations, we are going to be considering this value that we have here. Okay. So I think this value was, okay, let's close this again. Let's close this. And then we picked up from here again. So this value is about 50,000 kilonewton per cubic meters. So you want to edit the foundations reinforcement, you come to this provision of edit materials to be able to edit this. Okay, this has been done successfully. So I click on the OK options, and then for the slabs / craft shell element size, we go by 500 by 1000 millimeters successfully. Okay, now we proceed to floor mesh and analysis. You will click right there. So you give the program some seconds to carry out the floor mesh and analysis successfully. Then we proceed with our Raft slab foundation. So the process is done, you can see. So everything has been meshed together, as in combined together into a kind of a rectangular or a triangular squares, as you can see. So this is the final element method of foundations analysis. Okay, so we click on the OK options. Mind you, when you are at this page or this window, don't click on the close options, click on the OK option. So the process is completed successfully. Okay, all right, you can see analysis completed. Okay, so I will have to close this, or I can go to the analytical model using these provisions. So if I click here now, or I can close from here. I come over to these provisions where I have an analytical model. I can click in these provisions to see the analytical model. Okay, so you can see the displacement that we had on the structure due to the load, okay, that is being imposed successfully. And then the behavior of the beams. Okay, so this is not the foundations, all right? This is just the whole structure, like the superstructure. Okay, so I will navigate to the physical model, okay, right here. So I can come over to analytical model tab, and then I use the FE foundation model. So here we proceed with the design of the foundations. Okay, we just run the analysis of the foundation. So here we proceed with the design of the foundation. So you can see the behavior of the foundations due to applied load. Okay, so I will stop the animation. From here I come to where I have contour. So in the contour I will click on the contour. So once you click on the contour, you will see the effect displacement dialog. This one, originally it was the load combinations dialog that is actually here. So I click on the contour and I have this, and then I have my model being contoured just like this. And again, you have this key or legend which you will actually use to read the behavior based on the moment applied on these plate surfaces successfully. Okay, so you can be able to position the legend very well using these provisions. You see positions, top left, if you click here, top right, it goes to the right. You can see it here. If I use bottom, you can see bottom left, it will come here. So you can position it in where you can be able to see and read it properly. Okay, but we really have issue with this because the program will actually generate reinforcement based on the result here. So over here we have displacement, which is in the Z directions right here, that gave us this contour, and then the figures in the legend right here. All right, so we'll proceed to the forces. So I select in the forces F11, F22, F12, okay, and then V13 and V23 successfully. So all of this, you can see where the forces are intense based on the legend here. I go to the bending moment in the local axis M1, M2, and M12. Okay, and then I proceed to the design moment using wood and hammer. So I select in the mid both direction 1, okay, bottom direction 2, and then as well as top direction 1 and top direction 2. Okay, so this actually gives us the moment, okay, that happens at the point of node between these plates successfully. All right, so we proceed to the required steel area in the local axis based on the design moment in the local axis. Okay, based on the design moment in the local axis. So for the area of steel bottom direction 1, I select that. So I have the highest area of steel here to be 718.76, it's in Newton millimeter square per meter. All right, so this is the highest area of steel I'm actually having right here. So in the direction 2 of bottom, I'm having 500 and something. So for the top, you can see top is actually lesser. You can see the top is actually lesser. That means in this design, we'll probably be having our top reinforcement to be, lesser in diameter than the bottom reinforcement based on the area of steel we are having in the legend right here. So if I select in the top direction 2, you can see it's 160, which is very small. Okay. So based on the moment in the movement using wood and hammer, so we have to find the required steel area. So I select the first bottom, okay, direction 1, and I have just like not far from what I have in the moment in the local axis, moment in the local axis, and then the area of steel, not too far from what I had there. Okay, I select on the bottom direction 2. Okay, so bottom direction 2 will give us something 634.34 millimeter square per meter. So for the bottom direction 1, I'm having 189.64 as the highest. Okay, so bottom direction 2, I'm also having 176, which is within the range of the previous area of steel, okay, using local axis successfully. I select on the soil pressure to actually see where the pressure is actually intense. You see the color we had. If you check along the edges, you notice that the pressure is basically at the edges right here and also at the column points successfully. So having carried out all of this effect successfully, we proceed to the physical model. So we click on the physical model. So now we are actually done with the analysis using the finite element, and then we have also done with the design. Okay, so this process is the design process. This process we just go through now is the design process. Okay, so the next thing we will be looking at is the generations of the reinforcement. Okay, so for us to do that, we will first of all save this project, and then we'll navigate to the modeling tab, slab strips. So we start in the X directions. So in this type provisions, we use FA strips. It's going to be FA analysis. Okay, the source of analysis is going to be FA flow analysis, and then you click on this fixed band strip. Okay, pick that options. All right, so now we are going to be drawing the strips to generate reinforcement. So let's see how that works. I'll pick at the center point or anywhere along here as my first point. Second point, I click, so I have my reinforcement. You can see for the top I'm having 250 spacing, for the bottom I'm having 175, but the same area of reinforcement, but the spaces are different. Okay, because the pressure, okay, is much at the bottom than the top. Okay, so the same thing we are actually having also in this side. Okay, so now you see the Protastructure actually divided the reinforcement into two. See, the first one stops here. So the full length of a reinforcement is just 12 meters. So once a reinforcement or the building length is more than 12 meters, it's going to cut it and lap it. You can see it the way it is. So let us make progress. We want to spread this up to this edge. So for me to do that, I'll pick on design and update steel bars first. Activate this and pick this point. Take it to this edge. Pick, okay, and then click on the update. So you see the core line or rebar spine line is being extended to that edge successfully. So the same thing, I will pick this point again and then pick from this provision. Click on the update. It's also been extended successfully. All right, so we are done. We will still draw a strips in these provisions in the same directions, which is the X direction. So we will change the scope width. The scope width here, we will have to change it to the default, which is 1000 millimeters. Just like this, and then deactivate this at first now. So we draw in the X directions in this particular slab. Here I pick that point. So I make sure my hand is straight. I pick this point. So you see, I'm having my reinforcement being generated successfully here. So I will now pick this design and update steel bars. Okay, then I use this. Pick this first point here, and then click on the update. So I proceed. I pick here. I click on the update. Sorry. Right click to get rid of that. Pick this point and pick at the edge right there to expand the strips. Okay, successfully. That is done. All right, so now we'll be going in the Y direction. So I will select this for the Y directions. We pick from this point, but before that we will need to return this to the default, like the scope width. Okay, so I'll get rid of this. Change the scope width to 1 meter, just like this, after which I will now have to draw my strips in the Y directions, having selected the direction successfully. I pick from this point. I want to stop it elsewhere, so I'll hold the control key to actually have a straight line. I want to stop it here. So you make sure you have a straight line. So you see, we have it placed successfully, just like this, you can see. Okay, so we need to expand the strips to the edges of the structure raft foundation. So I will activate this, pick this point, pick this, click on the update. Okay, so I also pick this point, pick the edge, update successfully. The same thing applicable here. We need to have the vertical strips in the y directions, just like this. So also hold the control key to have a straight line and click. Oh, see, this is I did change this to the original. I did not change this to the original default width right here. So I can pick this point, click on design, pick this edge, and then update to bring it back to the edge of the slab right there. I pick here, just like this. You can see. So I have this designed successfully. So, but this seems to only design the cantilever slab. You can see right here. Okay, in these directions. So that is not an issue. You can see how we have been able to carry out the reinforcement generations at this footing base. Okay, so now the next thing we are going to be doing is the column drop at the foundation. So if I save this project right away, and then I navigate to the 3D, I need to have a drop at these foundations so as to support these columns against punching shear. Okay, so what I'll do, being at the foundation, just to select this, right click, and then I click on the drop slash slab patch panel. If I click on that, I will have this dialog. So in this dialog, I click on drop. So I can choose to use 1.3 by 1.3 column drops. Here it's going to be the thickness of the raft itself is what you're supposed to have here. So here it's going to be 250. For the reinforcement spacing, I will be using 150, just like this. Let's see. I click on the OK. This is being placed here. So I will do the same thing for all of these. So I will click on this. At default, this is always 1400. So you can change it to any footing size at all that you wish to actually use. Okay. So over here, I'll use 150. 150. Click on the OK options to have it. So having it for these two, we will actually use these two designs for other ones. Okay, because this is just to support the main slab raft reinforcement. Okay, it's just to support the main slab raft reinforcement. So let's navigate to the plan view to see what we have done right here. Sorry, no. So click in these provisions, right click, and then go to the plan view right there. So you can see if you select this or you select all of this, right click, and then you can show selected. You see the reinforcement here being created successfully, just like this. So I can select this, right click, and show all. So this is what I have. So in our detailed drawings, we will use this information for all of these other columns that you have not yet placed on it successfully, because we'll be using the same column footings or drops, dimensions, and depth successfully. Okay, so from here now we save the project. Having saved this project, now we will proceed to generate the drawings for this. So we are actually looking at this raft or floating raft foundations design, and not the real superstructural elements that we are actually looking at. Okay, so we are done with the design just like this. So we need to create the drawings now. Okay, so for the drawing, we will navigate to drawings and report tab right here, and then we use the Prota detail. So once you select on the Prota detail, this will load and actually take us to Prota detail, where we'll be able to generate the foundation drawing successfully. Okay, so let's give it some time. It's actually loading. All right, so here we go. I want to start by creating a new drawing because I wouldn't want all the drawings to be created. Okay, so I click your provisions. Then I come to where I have a form plan, expand it, and then foundation. Right click and draw. So in this dialog, I'll come to the option 2. Everything is set here. Come to option 3. I use your solid. I click on the draw options and then pick a point in the space to have it drawn successfully. So this is my foundations reinforcement I've drawn. So what I just need to do here is to cut the sections before I can take it to AutoCAD. So to cut the sections, you can pick from here. Then you have to pick the 2 points. First point, turn on the auto to have a straight line, and second point. So this is going to cut the sections just like this for you, and then you place it right here. Zoom close, you can see the sections right here. All right, so having done that, let's close this dialog and we will navigate to export this to AutoCAD, or you can still save it first. You can save it as, you give it a specific name before you export, or you can still export it from here all the way. You choose the version of AutoCAD you want to actually use to do the export, and then click on the export right here. So you give it some time, export is done, and here is the drawing. So you double click right here to have the drawing open in AutoCAD. So the drawing has opened successfully. You can just click on continue opening DWG to have it open finally. So here is the drawing in AutoCAD. Okay. So having this in AutoCAD, what you just now have to do is to now edit this drawing successfully. All right, so you will now have to edit your drawings. So as you can see, what I'm having here, this is Raft slab foundation detail. So this is how the detail of the drawing is supposed to be. And then here is the first, this is the 2 drawings you're supposed to have as your foundation detail drawings. Okay, so this one is general arrangement of the Raft slab foundations. Okay, so this is how it should look like. This is the slab thickness, and then these are the drops and the dimensions that will be used for setting out of this foundation. Then here is the reinforcement detail. Okay, so for the sections of this will look like this. So this is how the sections will actually look like. So this is from Protek company detailing template. Okay, so this is the informations for this type of foundations in Protek company detailing template. Okay, so if you get this template, you will have all of these drawings on it, which you can actually reference successfully. So here is the Protek company detailing template. You can see we have building on part 14 foundations. We have the steel building detailing template. We also have the building on pile foundation. We have the building on raft on beam or beam raft foundation. We also are building on wire strips as well as floating raft or slab raft foundation, which is the one we are actually designing. So once you click on any of these tabs, it is going to open the full drawings, including foundation details. Over here we have templates for robot structure, Tekla, and as well as Pro. You will be online to be able to access these tabs as well as the design report for pilot foundations and part foundations. How it is being organized, you get it here, but you must be online to click on that to be able to get the report successfully. So this template is customized to a fast-track our detailing process. So once you click on it, it automatically opens an AutoCAD detail drawing template customized to help you fast-track your detail drawing successfully. So the link to get this template is in the description of this video. So check the description of this video to get this template. It's just a small token to encourage the developer successfully. So this is the first and the second detail of this foundation that you actually need for these drawings for construction successfully. Okay, so once you follow this, is actually self-explanatory. You can be able to detail this successfully. So we are going to be stopping here. If you have any question, drop it in the comment sections. Don't forget to join our group chat. Check the link in the description of this video. Bye for now.